There are a number of ways to test the strength of your chassis design before you actually build it. What big companies do is they use computer modeling to do that. Tools such as SolidWorks or AutoCAD have additional function available that allows you to apply forces at particular areas of your chassis while holding other areas stable to see what happens, where things bend, where they start to break. And it's an effective way to really test the strength of your chassis before you spend the time and money to actually build it. Now, the catchphrase that this function goes by is called finite element analysis. And like I say, the major tools out there that do 3D CAD modeling, parametric modeling, have this function. Now, the problem is that it is somewhat expensive. Just to get an annual license sometimes starts around $800, many of them start around $1,500. That's per year. It's not a lifetime license, so you need to pay it every year. And that's just for the basic SolidWorks or AutoCAD style tool. The finite element analysis function is usually a premium option that you need to pay on top of that. So here's an example of finite element analysis being done on a race car chassis. As you can see, they're holding the center of the chassis steady while they flex either end of the chassis to see what happens. The brighter the color and the further it goes up to green, yellow, red means the greater the stresses on the chassis. So this is a great way to find out where your chassis is going to bend and maybe where you need to beef it up. The cost for these 3D modeling programs with the finite element analysis, FEA, is just an awful lot of money to spend for someone building a vehicle in their garage. So an alternative might be the locust method or the low-cost method for what a home builder might use. Now, the low-cost method starts off with the same idea. It's a finite element analysis, but we need to do it for a less expensive way. So we add on to that a method where we use balsa, a little leverage, and some over's glue. Now, like you might see here, that's kind of an old school method. It's the FEABLE method. But the real advantage here is it only costs about $8 per model. So let's apply the old school FEABLE method to the Tiger 700 project. Here you can see the chassis that I've designed for the Tiger 700. The colors of the tubes indicate the dimensions of the tubes. For the most part, the green tubes are 1x2 rectangle tubes. The blue ones are round tube, 1 inch in diameter, and the purple ones are 1/2 inch round diameter tubes. So here's my FEABLE model. You can see it's built out of balsa, just like the model. I built it to 1/6 scale, so all the dimensions are to 1/6, and the individual tube representations, that's here in balsa, are also to 1/6 scale, so I can also evaluate the the size of the tube as well. Am I using the right size tube? Now back here, you'll see this area right here, which is just a foam core box that I added on the back here. Now if you remember, this is based on a Raptor 700 engine, transmission, and rear suspension. I'm going to just basically cut off the front of it and add this frame. Now that's been proven by the Yamaha company, so I'm just basically treating like that as just an assembly, a block. So I didn't see any reason to represent that. So you'll see it's just a foam core block here. Okay? And if you look real close, you can see I've kind of put the engine on there. Just drawn it on with a piece of vellum. And then the wheels will be back here. But this is a proven piece by Yamaha. Now this whole 1/6 scale assembly only weighs about 30 grams. And for you people who are still haven't gone to the metric system, that's about an ounce. And most of that ounce, to be honest, is in this block. Okay, so it's very, very light. Balsa wood again, as you can see, just like the chassis. So just to give you an idea of how this material is, here's a piece of the balsa right here. Okay, just a piece of balsa, just like you build model airplanes from. And just to give you an idea, this stuff is pretty flimsy. That's all it takes to break it. So when you put it in a model, not only are you checking to make sure the geometry of your chassis is good and it's good triangulated out, but you're also testing the material strength as well. So instead of doing this on a computer model, basically what you do is you take it in your hands, kind of like this, okay, and you just start twisting. And I'm actually putting quite a bit of force into this. One of the first things you might see is right here. I'm putting torsional force in it, and if see if you can see this. You can see that front clip is twisting just a little bit there. So I'm going to put some additional gussets in that front clip. This is where the front suspension goes. Okay, so it's already told me that. And I can tell you I've already beefed this up a little bit based on my testing. So like for example, these two triangulated braces I put in because I was seeing some flex right in that area when I twist it and get on twisting it. Now there's one area I want to show you right here. Now the top part, you sit in here, and this is where the dashboard will go. Okay. And I thought a 1-inch tube would be the right size for that. But as I twist this, let's go ahead and twist it for you and see if you can see this. Let me get it in the camera. Now if you can see this, but that piece is twisting a little bit. Okay. So I didn't change it here, but I did change it in my design. That is now a 1 by 2 inch rectangular section because I'm getting some flex there, and it gives me a little bit more front end protection. Okay. And one of the reasons I went to these 1 by 2 triangular sections around the driver is to add some safety from side protection. So there's actually, I got 3 of those on the side. So I've got a fair amount of side protection as well as rear end protection. And now with this 2-inch piece around the dash, I'll have some additional protection here. So that's the FEABLE method of ensuring that your design of your chassis will work once you put all the time, effort, and welding, cutting and welding into your chassis.